right, here we have the book exercises from 5-7. These are very similar to the problems you're going to do on the green worksheet. Let's talk about A, and below the problems here, I have the properties written out, the red, the blue, and the green. Okay, 1A, log of 5 plus the log of 11. So what they're asking you to do is combine that, mash it up into a single log. And here's the rule, and the rule is in red at the bottom of the screen. We're actually going this way with the rule. Start here. You have 2 logs being added, right? You see that plus sign right there? You have 2 logs being added. What can you do with the m and the n? Here, multiply them. So instead of separately doing log 5 plus log 11, make it log of 5 times 11. So what's A? Not just 55, log 55. And what I want you to do is check that on your calculator. Is the log of 55, enter, the same as the log of 5, close it, plus the log of 11? Check it. Is the log of 55 the same as log 5 plus log 11? Should be the same. These rules work. These properties work. After we get to C, I'm going to go back to that warm-up when I said, is there any connection between 3, 2, and 1 when we were doing log of 100 and log of 1,000? You'll see how this all fits together. In B, I'm going to write in green because it goes with the green rule at the bottom. B, we can rewrite 3 times log 2 as what? Log of 2 to the 3rd power, which is log, what's 2 cubed? 8. So what I want you to do is check it. First type in 3 times log 2, then type in log 8. Should be the same answer. We're going to explore why later this week. There are proofs that go along with these. I'm going to make a video, a separate video on the proofs. If you would like to watch the video and learn about the proofs of these properties, it will be offered to you on the January 4th, 2013 test as bonus. Was log 8 the same as 3 log 2? Same, right? It's a little weird. It's a weird property to understand all of them until you go back to that warm-up and see why it works with that. I think it kind of makes a nice connection. So the log of 28 minus the log of 7 separately can be combined into division according to the blue rule. If you have subtraction of 2 logs, by the way, they have to have the same base for this to work. So we have 2 logs being subtracted. What can you do with their insides? Their insides, by the way, are known as arguments. Whether it's a square root, a log, an absolute value, a cosine, any mathematical operation that says the log of this, that x in there is known as the argument of the operation. So what can we do? The log of 28 divided by 7, which is 4. So to recap, in the first problem, we multiplied because of the addition to get the log 55. In B, we raised 2 to the 3rd power because it was 3 times log 2. And finally, in C, since they were being subtracted, the 28 and the 7 get divided to make log 4. Let's take a look at how that works with the warm-up from earlier today. Okay. So we did this warm-up, right? I'd like you to put your pencils down and watch this because this will make a nice connection, I hope, as to why this actually works. The third thing that we did down here was the log of 1,000 divided by 10, right? Log of 1,000 divided by 10. When you log something, you're finding the exponent that makes it true, right? The exponent that makes it true. So, could we rewrite 1,000 as 10 to a power to the third? Could we rewrite 10 as 10 to a power 10 to the first? Have we seen the 3 and the 1 before on this screen? Yes, right? And with the rules of exponents that we learned earlier in Unit 5, what do you do with these? When you have the same base and you're dividing, what do you do with their exponents? Subtract them. What's 3 minus 1? So it would be the log of 10 squared. Now this is asking you 10 to the what equals 10 squared? 2, right? The answer has to be 2. So not only does this kind of show you why you subtract, right? You subtract the 2 logs when you have division, but it also shows you that power rule. If you have the log of 10 base 10 with this exponent on it, what's the answer? What was the answer in this problem? The log of 10 base 10 with this exponent. What was the answer? 2, right? Well, isn't that the same as the 2 coming out front and multiplying by log of 10 base 10? The log of 10 base 10 is 1. And what's 1 times 2? 2. All right? So the warm-up from earlier today in a separate video was designed to show you why subtraction is involved with division, because it has to do with all about the exponents on the 10. Now, what I want you to do on the green sheet is go and do problems A, B, and C in number 1. Hopefully you got the answers. Your answers should be log of blah, and log of blah. You should have no separate logs. It should just be the log of one thing. So it's to rewrite as a single log.